Thank you very much, Stephen. My name is Gilbert Muhindu, and I'll be taking you through the possible techniques that we are going to use. Yeah, I'm going to start off with the supervised learning techniques or algorithms that we are likely to use. You'll pardon me for correlating the two because the two that I'm going to start with, that's random forest and decision trees, they are more or less related. Yeah, they're like brother and sister. The other one is the bigger brother. Yeah, so I'm going to start off with random forest, though it would have been much easier if I started off with decision trees. Yeah, in random forest, this is like the name implies, we have a large number of decision trees that, so basically in a random forest, we have very many decision trees combined together to get more accurate results. Yeah, like the name implies, it's like we have too much information, like there's a lot of information, thus making the visualization more complex as opposed to decision trees, because it combines very many decision trees. Yeah, this consumes more computation. More computation is required. The process of both generation and analyzing is also time consuming in the random forest. Yeah, so the random forest avoids and prevents overlifting by using multiple trees. Yes, for decision trees, it's a tree-like model where decisions are made with possible outcomes as a diagram. Yeah, excuse me. It's much easier to visualize. Yeah, though the results may not be as accurate as for the random forest. Then for the logistic regression, I'll compare this to the linear regression. And whereas the linear regression, the variables are dependent and continuous. For logistical regression, the data selected is categorical. For example, we have Boolean zeros or ones, true or false, yes or no. With both regression models, that's linear and logistic, we seek to get the relationships between the data inputs. And in our project, we are most likely to use logistic regression or random forest. We shall decide on which one to use. Then the unsupervised learning algorithms, we mainly looked at two unsupervised learning algorithms, the k-means and the hierarchical clustering. In the k-means, this is an iterative clustering algorithm that helps one to find the highest value for every iteration. Just to break this down, in the k-means, we have mainly clusters. So I'll give you an example. If we have two clusters, then our k will be equal to 2. Yes, our k will be equal to 2. Then we shall have two main clusters for the various data set info that we have. Yes, so in each group, it's defined by creating a centroid for each group. Yeah, in hierarchical clustering, the algorithm builds a hierarchy of clusters. This is much easier to understand. Like the name, it's a hierarchy, begins with too much, like a bigger set of data. Then by the end, like it will break down the clusters into very many. Then by the end of the algorithm, we shall have one cluster left. In our project, we are going with we are going with the k-means. K-means is why we are going with the k-means. It's because of the data we have. We shall have two main clusters, so it will be very easy for us to get our desired output with the kind of with the nature of the data we have. So next I will take you through precision, recall, accuracy, and F1 score. So accuracy is I'm going to refer to things like true positive, true negative, true positive, true false negative, and false positive. So accuracy is mainly is simply the ratio between the predicted observations, correctly predicted observations to the total observations. So it's a ratio. In mathematical terms, it's basically the true positive plus the true negative out of a summation of everything: true positive, true negative, false negative, and false positive. So accuracy is the formula of accuracy, like shared, is TP plus TN out of TP plus TN plus FN plus FP. And precision is the ratio of correctly predicted true positives. Is the ratio of correctly predicted for positive observations to total predicted positive observations. So precision is TP, that's the true positive, out of true positive plus false positive. So basically in precision, we just want to get the exact positive observation. Yes. That's why we take out in the formula, it has false positive to get the exact positive observation that we made. Yeah. Then recall, which is also known as sensitivity or true positive, is the ratio of correctly predicted positive observations to all observations in the actual class. In the actual class, yes. What this means is the recall is us trying to get the true positive, the exact true positive out of the exact true positive, because we shall have the ratio of the true positive to the true positive plus the false negative. The false negative being the value which was supposed to be true, but according to our algorithm, we got it as negative. I don't know if that is clear. Yeah. Yeah. So like I mentioned, sensitivity is the same as recall, or also referred to as true positive rate. Yes. So F1 score is the weighted average of the precision and recall. Yes. So in our project, we are most likely to use the F1 score and precision, which takes care of, which provides much better accuracy, which provides much better accuracy than all the others. Yeah, so those are some of the references that we used. in our algorithm. These are more references where we got our data from, where we got all the information from, and th these are some of the acknowledgements. Yes, thank you very much. Okay, that's the end of our presentation.